Good day, learner. I am Ademola Oyetunji, a physics teacher from Osun State, southwest part of Nigeria. Good afternoon. Have you ever wondered what is the difference between the sound wave and the light wave? The difference between the sound wave and the light wave is in the classification of the wave into either mechanical wave or electromagnetic wave. The sound wave, as we all know, is a longitudinal wave. The longitudinal wave in the sense that the direction of traveling of the wave is parallel to the direction of propagation of the wave. In that case, the longitudinal wave now set up a region of high pressure in the air and low pressure in the air, causing what we call the compression and the rarefaction. The compression and this rarefaction constitute the waveform that look like the crest and the trough that we explain when we are considering the general wave form. Let me now take you through this. In this video, we are going to show you the relationship between the velocity of sound, the wavelength, and the frequency as they are relating with each other. In this video also, we are going to work examples and determine the factors that can affect the speed of sound in air. Here we go. The learning outcome are this. By the end of this video, you should be able to 1. Derive an equation for the velocity of sound. 2. Solve simple problems on the speed of sound. 3. Explain the factor that affect the speed of sound. The speed of sound is defined as the time rate of distance traveled by the wave particle, that is, the distance traveled by the wave divided by the time taken. The unit of the speed of sound is the same thing as the speed that we know in the rectilinear motion, which is meter per second. The distance between two successful compression or rarefaction is the wavelength of a longitudinal wave. The time taken for a wave to complete one oscillation or circle is defined as the period. Meanwhile, the numbers of circles that a wave completes in 1 second is called the frequency. By so doing, there is a relationship between the frequency and the period. That is, frequency is the reciprocal of the period. By this definition, speed is equal to distance all over time. In this case, we are talking about the distance between two successive rarefaction or two successful compression, which constitute the wavelength. The wavelength is the distance covered to make one complete oscillation, and the time taken for that is the period. Speed is now given as wavelength all over period. As the period is related to the frequency as 1 all over t, we can see that we can have the speed of the sound to be represented by capital V and the frequency to be represented by F, where the wavelength is represented by lambda. So the relationship between the three is now V is equal to F. Working example. A source of sound of frequency 500 Hz emits waves of wavelength 60 meters in air. What is the velocity of sound in air? Solution. We are given the frequency to be 550 Hz. We are given the wavelength lambda to be 60 meters. The velocity of sand in here is what we want to calculate, so we don't know, we put a question mark. From the relation that we just determined now, V is equal to F lambda. Since F is given to be 550 and lambda is given to be 60, by the time we multiply the two, that is 550 multiplied by 60 is equal to 33,000 meters per second. Question number 2. A source of a sound wave of velocity 350 meters is directed towards the surface of water. If the ratio of the wavelength of sound to that of the air is 425:100, calculate the velocity of the wave in air. We are having two velocities in this case, the velocity of sound and the velocity of sound in water and the velocity of sound in air. We represent that one by V1 and V2. So V1 is given, V2 is not given. And we are given the ratio of the wavelength as 425:100. So by the time we find the comparison, we can say V1 over lambda 1 is equal to V2 over lambda 2. 350 divided by 100 is equal to V2 divided by 425. After our multiplication, we get that V2, which is the velocity of sand in water, is equal to 350 times 425 divided by 100. Our final answer gives 1,487.5 meters per hour. Factors affecting the speed of sound include 1. The speed of sound is fastest in the solid, which is the medium, like steel or iron, followed by the liquid like water or kerosene, followed by gas like air or helium. As you can see in the table, the velocity of sound in solid like iron is 5,100 meters per second. That of steel is around 5,960 meters per second. Liquid like water is around 1,500 meters per second, as gas like air is around 330 meters per second. The speed of sound is the least in the air, and it is the fastest in the solid like steel. Other factors that affect the speed of sound in air are the temperature. 2. The direction of the wind. The velocity of the sound is proportional to the square root of absolute temperature, which means the higher the temperature, the faster the speed of sound will be in air. And that is why the sound that is audible and pleasant to the ear in the morning, in the noon, it will relatively become unpleasant to the ear. Self-assessment. Deduce an equation for the speed of sound. Mention two factors affecting the speed of sound in air. The velocity of sound wave traveling with a velocity of 360 meters per second is 60 meters. What is the period of the sound wave? 3 seconds. Conclusion. The velocity of sound is given by wavelength all over period. Frequency is defined as 1 all over period, that is F is equal to 1 all over T. Sound travels faster in solid like metal. Sound travels slowest in gas like air. Temperature affects the velocity of sound in air. Direction of wind also affects the speed of sound.